And today we're going to do a Steam operation overview. And I know we did a brief overview of the Steam Tsunami2 in our first webinar. And so we're going to dive a little deeper into the Steam. We're going to talk about some of the background sounds and things like that. So first off, real quick, for those of you guys who are new here, welcome. I appreciate you joining us for today. My name is George Bogatuk. My primary function here is a product specialist. I work with the sales department, the support department, and engineering departments on all different fronts, making sure that we're bringing out the best product and keeping everything current and up to date. We're going to kind of overview Tsunami2 Steam. We're going to go and review all of the functions and different effects in the decoder that set us apart. You know, we have and had current and former railroaders on staff, and so when we use their experience to make the decoder and create features for you guys, we're trying to make the most realistic simulation of a steam locomotive as we can, but also make it easy enough that any of us can use the features. I know I personally have never run a real locomotive in my life, but knowing all of the features and how they work really helps me gain that extra experience and, feel a lot more close to actually running a real thing. One of the other things that sets us apart is we do have 16 independent sound channels. And the reason this is important, our nearest competitor boasts that they have 10 sound channels. And the reason is because with so many different sound effects, I mean, we've got over 50 different sound effects built into the Tsunami2. And so we want to make sure that the decoder is able to play all of those sounds at the same time and not cut one sound off. Some of our competitor stuff, you'll hear the air compressor sound, for example, disappear when you turn on the bell. And that's because they only have a limited number of sound channels. And so they prioritize the bell over the air compressor sound because they figure the compressor is a background sound. You don't need that. But the bell is one of the more dominant sounds. And with 16 independent sound channels, it allows us to be able to play all of those. And that's going to be very important as we go through here, because once we start showing a lot of these features that are working and how they work with the prototype, and then we'll play as many as we can on our locomotive here on the table, you'll see how now you're not losing out by using this Tsunami2. And then last, we're going to show how they relate to the prototype, and of course how we add more fun and more enjoyment to our operations. First thing here, how does the steam locomotive work? I mean, there's a lot of simple stuff. The coal is stored in the tender and is put into the firebox, and that fire is used to create heat. The heat, of course, boils the water and creates steam. Now, up at the top there, you're going to see inside the dome there where you have what's called the dry pipe. And the dry pipe is what allows that steam pressure to vent down and be used for the cylinders. But if you look closely at this drawing here, you're going to see the dry pipe actually pump back through the flues. And what that's doing, that's called a superheater. And what it's doing is it's taking the heated steam and basically running it through there again to heat it up a little bit more and add a little bit extra pressure to it. And then it's sent down and put through the valve and then ultimately into the piston and the cylinder, and then vented out through the smokestack. Now, a couple of things on there, you'll see the coal auger or the stoker, and that's how the coal, in this case of fairly large locomotives, is drawn automatically. Fairly large locomotives, the firemen had to shovel all that. It would become very backbreaking work, and they would never be able to keep the fire up. And then also you notice the water line is in the tender there is below the coal, and basically water draws down by gravity. So you see the pipe that carries the water from the tender below the water line over to the locomotive. And then we have the injectors, which will pressurize that water and force it in through the check valves. And we'll talk about all of this here. And then of course you have your steam dome, and then you have what's called the turret. The turret usually sits right in front of the cab. And that's also using steam pressure to run other appliances on the locomotive, such as the Dynamo and other features like that. We'll talk about those as we go through the process. So again, having real railroaders on staff, understanding how all this works and how everything is tied together, we can make a more realistic sound effect, because a lot of our sound effects are based on each other and how you use the decoder. It's not just making random noises in the background. Anybody can do that, but we take that extra step to make sure we're bringing you that realistic experience. So when we're going through the setup here, we're going to do a few things. We're going to talk about these CVs, CV112, where we'll adjust the fuel type, injector, cylinder count, things like that. CV114 will adjust the chuff rate. CV120 will select the whistle. 122 selects the bell. 123 selects the exhaust chuff. 124 selects the air compressor, and 125 selects the dynamo. So like I said, we're going to go through each of these here. In our Tsunami Steam 2, we do have 90 choices in there. So when you select CV120, you can go from 0 to 89, and that 0 being a choice makes 90. And so you can match pretty much any steam locomotive whistle that you can have. The other thing, then, and we've talked about this in the past, is that, you know, back in the steam days, there were a lot of times where engineers had their own whistle. And usually when they were assigned to a train, they would climb up and put their whistle on their locomotive for the day. And a lot of times townfolk knew old Bill was running the train because they can hear his Hancock 3 chime or whatever the case is. We're going to go ahead and show you real quick. So I'm going to unmute this locomotive here, and I'm going to play the whistle that's on.
We have long and short blasts of the whistle. And for real quick reference, this is the safety valve that's popping off. And we'll talk about that a little bit later. So when I select the whistle, I just simply take CV120, and using my Steam sound selection reference that you can get on our website at SoundTraxx.com, you can go through and see the list, and by setting the CV value to the number that corresponds to the whistle you want, you can then simply select that. So looking at the list here, let's take a look. Let's do a Nathan Step Top 5-chime yard mix, which is whistle number 38. So now when I blow the whistle, and you'll notice that we have long and short blasts of the whistle, and this is so that we can faithfully reproduce whistle signals. All of these have different recordings of each. So let's do a couple more here real quick. So let's do whistle number 81, which is a Hancock short bell 3 chime. So we're going to set CV120 to a value of 81. That's a pretty good whistle there. So we're going to go ahead and leave that one. But you've got 90 to choose from. Go through, listen to them, play around with them, decide which one you like. I have a friend of mine that runs his trains, and every single time he changes the whistle when he runs them. So he's really loving this feature. Also, you have independent volume control of every single one of our sound effects. And so in this case, CV129 will select the volume, or will adjust the volume.
All right, CV122 selects the bell and the ring rate. So it'll select which bell sound plays and the ring rate at which it's done. What we've done is we've taken each of these bells and recorded them at different ring rates so that way you get a true resonance of what that bell sounds like. So in this case here, by default,
our bell is selected here. It's the heavy brass with a medium ring rate. So when I ring the bell, you can kind of hear that fast ring rate. Well, if I take that same bell and do a slow hand-rung ring rate, we're going to take CV122 and we're going to set it. And you can kind of hear how you get that backswing of the clapper in the bell now. So for our example here, we're going to set this to a medium brass, medium ring rate. So we're going to set our bell to a value of 12. So you can hear how that bell sound changes based on how we select it.
Now there's 54 different recordings total with different ring rates and different options, including air rung and all kinds of different bells. So you can go through and just make that customized adjustment. And then, of course, our volume is set in CV130. Now, the next one here is going to set up, this is a pretty important one. And what this is going to do is this is going to set up our entire locomotive based on what we're doing. And this is going to set up the profile. So we're going to select the type of fuel that's being used, whether it's a hand-fired coal, auger-fed coal, or stoker, wood burner, or oil with an atomizer. And you can select this, and this will change the overall profile. So when Fireman Fred is, quote-unquote, shoveling coal, you'll actually hear shoveling coal. But then if you change to wood, you're actually going to hear a crackling fire as he opens the firebox door, and you're going to hear wood being thrown onto crackling wood fire. So all of these sounds change based, again, on what you're doing and what locomotive you're installing it into. Next is select the type of injector, whether it's a lifting or a non-lifting type injector. So you've got a lifting or a non-lifting type injector, and we'll talk about the injector here a little bit later. you can select a manual or a power reverse, and the manual Johnson bar determines the direction, and a power reverse, as locomotives got bigger, you had an air-assisted power reverse, and so that way they could move those linkages because they started getting big and heavy. You can also enable the articulated and a 3-cylinder chuff cadence. So a conventional rod where you're going to get the 4 chuffs per revolution. You can also set an articulated chuff where you get 8 chuffs per revolution, or a 3-cylinder where you're going to get a slight offbeat 6 chuff per revolution. Bits 5 and 6 there, it sets an articulated slip rate. And in this case, here's Fireman Fred shoveling coal real quick. You can hear. And we're about to change that. So in this case, going back to the topic, the articulated slip rate is the sound of the 2 sets of drivers going in and out of sync with each other. And so you can do that at 4 slip rates: none, slow, medium, and fast. And you can decide for yourself how much you like it. And that's only relevant to the articulated because a simple articulated has 2 independent engines underneath the locomotive. We're going to play around here a little bit. So first off, we're going to take CV112 and we're going to set it to a value of 10.
And this way, when you heard Fireman Fred shoveling coal there, but now we're going to turn it to an oil burner for a moment. You're going to hear the atomizer kick on. So now you can hear a little bit more of that oil burning atomizer running in the background. And the same thing will go for a coal stoker. So you'll hear the different sounds based again on what your profile is. So for this locomotive, we're going to take CV112, we're going to set it to a value of 3. So there's your coal stoker, and we have a manual Johnson bar. So when I change directions, you can hear that. Real quick, I'm going to let you hear the power reverse. So when I change directions here, now you'll hear the power. So this is all selected in CV112.
So next up, CV114. Now we're going to do this to select the chuff rate. Now CV114 basically will tell the decoder how many chuffs to create per revolution of the motor. And this is a key point because in our previous generation products, the decoder was creating chuffs based on the throttle command. And so therefore a chuff cam or such was absolutely necessary. But now with the upgraded motor control technology and the back EMF algorithms, we're able to identify the rotations of a motor. And so when you set CV114, we're actually going to adjust the chuff rate based on the rotations of the motor. So when the motor stops, the chuff doesn't continue because the motor isn't rolling. Real quick, we're going to kind of do a real quick simulation on how we would set the chuff rate. So we're going to get this guy
I'm moving here at about speed step 5. And we can kind of see that we're not getting 4 chuffs per revolution. We need to speed the chuff rate up a little bit. So we're going to go ahead and take CV114. We're going to set it to a value of, it's defaulted at 57, so we're going to set it to a value of 50 and see how that sets. You can see it's still just a little bit slow, so we're going to go ahead and take CV114. We're going to set it to a value of 45. And that looks a little slow, so let's go ahead and set it here. We'll try to tune it in. We'll set it to a value of 47. So that looks pretty good right there. And just to show you how that works, I'm going to go ahead and put a little resistance here on the wheels. We're going to stop the rotations of the wheels. And you notice that the chuff disappears. And as soon as I let go, you hear that chuff return. And again, that's how we're doing the chuff rate. It's watching the rotations of the motor. Now, the other thing I wanted to mention is there is an intelligent chuff algorithm that's built into the decoder. So when you're moving at faster speeds, you don't get that helicoptering or a machine gun type sound effect. When the real locomotive is running at speed, you're going to get a much smoother, more realistic
whirring sound, whereas with previous generations, it was cutting off the sound to play the next sound. And so we put an algorithm in there to help give you a much better experience, especially when running at top speeds. Now, next up, we're going to select the chuff, CV123. There are 10 different exhaust chuffs, including 3 light, 3 medium, 3 heavy, and a geared. We're going to go ahead and move this guy
about speed step 5 again. And to simply select the chuff, I'm just going to change CV123, and I think it's one of the medium heavies or medium chuffs right now, so we're going to change it to a light chuff, so you can kind of hear how that chuff changed. And we can do this again to determine which one we like. So now we're going to pick one of the heavies. So you're going to hear how that chuff changes. So you can go through and match it up to kind of what your locomotive would like, you know, which one it is. If you've got a really light
steam locomotive like that 440 there, or if you've got a really heavy big boy or something like that, you can go through and adjust that. We're also going to talk about the blower, but the CV123 will also select which blower sound is playing. Chuff volume is set in CV131. Now, when we factor in the chuff, usually cylinder count is one of the things, and we talked about that with CV112, where you have 2-cylinder, 3-cylinder, or 4-cylinder, and you can do this in both the Tsunami2 and our Econami product line. Now, we also have a feature in our Tsunami2 called Dynamic Digital Exhaust, and what this will do is this adjusts the intensity and tone of the exhaust chuff based on what the locomotive is doing. Changes in the throttle and things like that. So when you're running on flat level track, you'll hear one tone, but then we put some resistance on the wheel to simulate running up a grade, for example.
And then you're going to hear a heavier chuff. So we're going to get going here a little bit faster. And what I'm going to do is I'm just going to put a little resistance on the wheel here. And you can kind of hear how that chuff intensifies versus when I release, you hear that chuff back off. Now this is the dynamic digital exhaust. Now one of the things to point out is our Econami product line does have a dynamic digital exhaust.
But it is a throttle-based dynamic exhaust only. And so basically when there's changes to the throttle, as the decoder motor speed is adjusting to match the commanded speed step from the DCC system, it then will adjust the tone of the chuff based on that. But once it reaches speed, it's going to maintain that same chuff throughout the entire run. So you want to make sure to get the Tsunami2 to get the dynamic exhaust that will change based on changes in load or grade or any of that kind of stuff. So as a result, we do need to calibrate. And to calibrate the dynamic exhaust, we're actually going to take these 2.503 and 2.504, and we're going to set those to 255. And what this is going to do is this is going to tell the decoder basically what the power consumption is of that motor, how much power it uses at whatever speed step. And then it uses that as a reference. And when the decoder needs to send more power to the motor, for example, going up a grade or something like that, then that chuff will intensify and you'll hear the change in the chuff. If you go and downgrade and you have the cars pushing against the locomotive, it doesn't need quite as much power to go downgrade. And so therefore you're actually going to hear the chuff back off. So how do we do this?
Typically, you'll run the locomotive for a couple of minutes, just kind of loosen it up, get the grease warm, and let all the mechanicals work together. And then to do this, we're going to set CV32 to a value of 2, and that's going to be the 2-dot part of our CV. And we've done videos on our YouTube channel about that, and we've talked about it in prior webinars as well. So CV32 to 2, and then with the locomotive running at speed step 1, we're going to go ahead and we're going to set CV203 to a value of 255. And what that's going to do is that's going to interrogate the power consumption of the motor, and it's going to reassign the CV value to another number other than 255. And you can go back and read it, you'll get a different value. But we're going to set 503 to 255, and now the decoder has calibrated the power consumption for the motor. Now the second part of this is CV2.504. We're going to set that to a value of 255 when the locomotive is running anywhere between speed step 20, 30. You can do it at speed step 10. The decoder will calibrate it, but we recommend around 20 or 30. And the reason is it gives you a little bit more distance between those points on this chart. Typically, if you run your locomotive at speed step 40, then calibrate it at speed step 40. So to do this, we're going to get going here at about speed step 25. So we have to wait a minute to let the decoder get to speed step 25. Now once it settles in, we're going to set 504 to a value of 255. So now the decoder's been calibrated, so we'll go ahead and bring it to a stop. The third part of this is CV2.512, and that determines how sensitive the decoder is going to be to changes in the load. It's defaulted somewhere around 60 or 64, I believe, which is a good number for our steam locomotive, but we can go ahead and set that higher just to enhance that feature. So I'm going to take CV512 now, and just to show you, I'm going to set it off to 150. And now when I run my locomotive, we'll get going at speed step 10 here. And once we're at speed step 10, you kind of hear the chuff back off. But now again, I'm going to put a little resistance on the wheels, and you can kind of hear how that chuff is changing and getting louder. And then when I release, you can hear that chuff back off. So this is how we set and calibrate the dynamic digital exhaust. I definitely encourage you to do it. However, I will say on our steam decoder, it is set up out of the package so that you can enjoy the dynamic exhaust right away.
Now next up, we're going to talk about function assignments. Now with over 50 different sound effects, and again trying to give you the feel of running a real locomotive, there's a difference between automatic and triggered sound effects. And you can go through here and you can trigger certain sound effects, and we'll talk about a lot of these here in just a minute, but this is the default function mapping. And a really quick, nice little side effect of the Tsunami2s is that we can go through and set this function mapping chart to whatever you want it to be. You can take any function and assign it to any button. So when the decoder receives an F7 command, for example, if you don't want it to dim the headlight, but you want it to apply the brakes, you can set it up that way so that you can have those buttons do what you want it to do on your locomotives. So this is just the default sound effects, and so we're going to go through and talk about some of the more detailed effects. Now, kind of going along with the chuff, we do have a working cutoff. And using the F5, which is the Johnson bar forward, and then F6, which is the Johnson bar reverse, you can kind of just manually adjust the Johnson bar to adjust the overall tone of the exhaust. So let's get going here about speed step 10.
And this way you can hear. So we're going to get settled in. So when I press the F5, what it's going to do is it's going to shorten the amount of time the valve is applying steam into the chest. So when I push the F5 button, you kind of hear that chuff change. Now I'm going to turn on the F5 again. You kind of hear that chuff as it's getting a little bit more abrupt. And just to kind of show you this, I'll put a little resistance on the wheels. And you can hear how abrupt that chuff is. So let's do it again. And you're kind of hearing how that chuff is changing. Now the last step, you've got 3 sets, and then the fourth turn on to the F5 goes into drifting mode. You'll hear the snifter drop, you hear a leaky valve packing, and now you're just basically hearing the rod clank. And this will run this way as long as you have it. So regardless of the speed step, I can increase or decrease my speed, and you will never hear that chuff because now we're fully drifting. But now to re-engage my chuff, I'm going to turn on the F6 key. And the F6 is now moving my Johnson bar back away from me. So you can hear that snifter lift, and you can hear that chuff coming back into play. So now you can kind of hear that. And the F6 now is going to adjust the Johnson bar again. You're hearing that chuff change. And then the fourth activation of the F6, you can see how now we're back to a full adjustment of that valve. So this gives you the ability to have the decoder automatically do it based on load, or you can do it manually based on what you're doing. Now when we talked about drifting,
this is the last notch of the cutoff. We can go through, and really when we're going downgrade, you can feel that drifting or do that full drifting effect. So as I talked about, we have the new rod clank recording, which is, to me, it's a really cool feature. Rod clank is something that doesn't go away, so you can have that come on all the time. It's just more prominent when you're drifting. Leaky valve packing, and then we have the lifting and dropping of the snifter valve. So next up is wheel slip. So as we're moving our locomotive, we can engage function 19. And what you'll hear is you'll hear the drivers break loose of the rail and start slipping. So in this case, the wheel slip is defined as the wheels breaking contact from the rails. Typically heard when trying to start a heavy train, or if you're on wet rail or going up a grade, something like that. So
we're going to go ahead and move it about, I'm going to set the throttle to about speed step 10 or so. And when I enable function 19, you'll hear the wheels break loose, and then the engineer will back off the throttle. He'll reapply the throttle gradually until he gets the wheels back under him and then goes. So let's hear it again. So you can kind of hear that sound effect. It's a really neat little sound effect. When we were designing this particular one, we actually thought that we should have the wheels break loose as well from the rail.
So we thought about applying a little bit extra voltage to the motor to get it turning and cause the wheel slip. But then we remembered things such as traction tires and stuff like that. So we decided that it will be just a sound effect for the time being. Next up is our Dynamo. And the Dynamo is our steam-driven electric generator that sits on top of the model. Let me show it to you here on this locomotive. And you can
kind of see the Dynamo sits right in here. And what this is a steam-driven electric generator. And what this does is this applies electrical power to things for the headlights and stuff like that. It's applied with the F0 key, so when I turn on the F0, it turns on the headlight, but you'll also hear the Dynamo spool up. And then as one of the features of the Dyno light, or of the Dynamo, is our Dyno light for the headlight. And so as the light turns on, you'll see that light steadily increase as electrical energy is now being sent through the wires on the locomotive. We've done a YouTube video on that, so be sure to check that one out as well. And I can go through and select different dynamos. I can go through and in CV125, I can select from different dynamos. So let's go ahead and change so you can hear different one here. So we're going to select Dynamo 1. So now you can hear that high-pitched Dynamo spool. And I'll be honest with you, and I know not everybody's around steam locomotives like we are here in Durango. And so we've had a lot of people call up and say, what's this loud interference sound that I'm getting out of the speaker? I don't understand. Did I wire something up wrong? And not everybody's around steam locomotives. And so to tell you a little personal story, back when I was living in Texas, I heard that the first time I turned on my original Tsunami, and I thought, oh my God, that's terrible. And so I turned the volume down to 0. Then I went and chased a steam locomotive and heard it and said, oh, well, actually, that's a pretty loud sound. So I went back home, and the benefit was I just set my volume again, and it came back on. So you have 8 different dynamos to choose from. So you can go through and adjust it, including double dynamos and triple dynamos if you're running some of the more modern locomotives. So it gives you the ability to adjust. And then again, volume setting is set in CV133.
So the next step is we're going to talk about the cylinder cocks. Now this is something new to Tsunami2 and Econami, and the cylinder cocks are a valve that usually sit at the bottom of the cylinder, and as water condensates when the locomotive is stopped, it'll turn into water. And when the steam condensates, you don't want it to be water because there's such little clearance between the cylinder head and the edge of the piston. Water doesn't compress the same way steam does, and so if water condensates, you can potentially blow the cylinder head off. So you want to make sure that you blow out any potential condensed water. So typically after the locomotive's been sitting for about 10 or 15 minutes or so, the engineer, to get going again, will then open the cylinder cocks. So let's go ahead and show that for you. So we're going to go ahead and move to step 1.
Turn on our cylinder cocks. And we'll go ahead and throttle up a little bit. And we can turn it off. Now the advantage to our Tsunami2 with the cylinder cocks is most of the our cylinder cocks effect can be set up either automatically when your locomotive starts, or it can be done manually with the F4 key. Now, one of the other advantages that you can do is, let's say for example we want to run our locomotive a little faster. Well, there's a lot of times where the firemen may accidentally put too much water in the boiler, and they'll suck water into the dry pipe. It's called oversaturation. And so the engineer obviously, or they would have to blow that water out of the system So at speed, we can still turn on the F4 and turn on and blow out that extra water. So if you want to play around a little bit and simulate the fireman oversaturating the boiler here, you can do this at speed. That's one of the things that you can't do with any of our competitor stuff, because again, here's where knowing how the locomotive operates and knowing how the steam locomotive works is where it really pays off. So you can more accurately represent the locomotive that you're modeling. And then again, our volume level is set in CD 136.
But when we're chasing real locomotives, who doesn't like to see the smoke billowing out from around the steam locomotive as it's running? And so in excursion services or demos and stuff like that, they tend to leave the cylinder cocks on a lot longer than what's absolutely necessary. It's all about the show in that case, but it's a really cool effect, and you can adjust that for yourself. Next up is function 10, which is the blowdown valve. This is a valve that's located on either side of the locomotive next to the firebox, down at the bottom of the water where the boiler would be. And what this does is this allows the engineer to blow out any impurities or any sediment that have gained in the water. So when we're running our locomotive here, we can open up the blowdown valve.
And you can hear it, and then we cut it off, and it'll shut down. So this is another example of operating and using the actual steam locomotive, again, where you want to and how you would in the real world. Now the next up, we're going to talk about brakes. Now I know we've talked about this a lot.
This is one of the really cool features that we built into as far as operation is concerned, but we'll cover it very briefly here. F11 activates our brakes. It basically turns our brakes on and off, just like it did in the original Tsunami and the Econami. But Tsunami2 actually supports both types of brake systems that you're going to find on a locomotive. The independent brake, which as its name implies, is the brakes that are actually on the locomotive and stop the locomotive independent of a train. So when you turn F11 on and off, you'll hear the independent brake. Or the other braking system is the automatic, or what's known as the train brake. And this distributes the braking effort throughout the entire train through the cars that are being towed around. Now, when you turn F12 on, it will then trigger the decoder to go into train brake mode. And so you'll hear a whole different set of sounds. So really quickly, we'll show you the sounds when we're running.
So we're going to move our locomotive here to speed step 10. And with F12 off, we're going to use the brakes. We're going to stop our locomotive. And then we're going to stop, and then reduce the throttle, and we're going to release the brakes so you can hear the independent bail off. Now, that will work, and you can stop the locomotive with the braking rate, and that's set in CD 117, 118, and we'll get to talking about that in just a second. But the next one is when I hit the F12, you're going to hear the train line charge as we go into train brake mode. So when you hear that, you're going to hear the compressor start to cycle more frequently. Because now the compressor is going to automatically work to charge the train line. And again, you don't have to push a separate button to do air compressor slow, air compressor fast, or anything. The decoder is going to do this all based on what you're doing with the locomotive. So in this case, all we're doing is moving the engineer's hand from the independent brake handle down to the automatic. So now when I run my locomotive, again at speed step 10, when I do my F11 application, you're going to hear the air reduction in the cab, and you're going to see that the locomotive comes to a stop. So I'm going to reduce my throttle, and I'm going to release the train brake, so you'll hear the different sound effects. So all of those are set up to be run automatically based on how you're using the decoder and how you're using the locomotive. So when we go to this, F12 is basically our toggle between the independent brake and our automatic brake. When F12 is off, we're going to be in independent brake mode. When F12 is on, we're going to be in automatic. And so you can hear the sounds, and it's all going to play based on how you're doing and what mode you're selecting. Now, the other thing to note is all of our sounds are interactive, and so they work based on how you're using the decoder. So in this case, when you're using the brakes more frequently, you're also going to hear the compressor cycle more frequently as it's running, because when you're using the air that much, you're depleting the air reservoirs. And so the compressors will then trigger automatically with a governor to then fill up the air reservoirs and make sure that you have the air pressure you need to control your train.
Now, when you're doing this, CVs 3, 4 are acceleration and deceleration rate. CV 117 and CV 118 set up our braking rates. And then, of course, our volume controls are in CV 138, 139, and 140. And these are for my independent brake apply, my independent brake release, and my automatic train brake sound effects. Now, the last thing I'll mention on this is when you have our product called the Sound Car in your rolling stock and you've consisted them together, when you set up into train brake mode, when you set the brake on, you're going to hear the air reduction in the cab, but you're actually going to hear the squeal distributed through your train from the sound car decoder, because they're all going to be working together. They're all coordinated as far as speed is too. So when you bring your train to a stop, your squealing and the sound cars are going to stop as well. So when you set these CVs, you want to match them up. It's a really cool sound effect. I know we've done some videos on it, so be sure to check out our YouTube channel for more information. Now, once we get into other sound effects. Now, we've added a lot of other sounds for servicing. So the photograph there is a layout that I've been to and operated on. It's a gorgeous layout, but hostlers are basically pulling locomotives out, spinning them on the turntable and throwing them on the ready track. But now we've got a lot more sounds that we can interact. So for example, F15 is the sound of wheel chains being placed. The steam locomotive doesn't have a handbrake like a diesel engine or a freight car does, and so they put wheel chains around to keep it from rolling independently. If you're out on the high iron and you've got a water stop that's coming up, you can actually do function 16. So let's just listen to it. When I turn on F16, you'll hear the water stop.
You hear the tender hatch open, and you hear the water pouring into the tender. And then when I turn F16 off, you hear the water stop and the tender hatch close. Function 17 is the same type of thing, and it's for fuel loading. So if we've selected wood, coal, or oil, you'll hear the appropriate sound putting in. So again, if you're at a layout where they have coaling towers like you see there in the photograph, we can turn on simply function 17. And you're going to hear coal pouring into the tender. We turn 17 off, and you'll hear that stop. Now the last one here is an ash dump or shake the grates and cleaning the fire. So when we turn on function 18, we stop our locomotive, in this case over the ash pit. We put on function 18. You're going to hear the air wand, and you're going to hear them shaking the grates, cleaning the ashes out of the firebox. And it'll run as long as we have function 18 on. So we'll turn it off.
And you hear all that go away. Now the advantage here is so now our hostlers can be a lot more involved in getting the locomotive ready rather than just simply bringing it out and then going on to the next one. We can add a little bit more fun and enjoyment into there. And then same thing on the road. If you're on the road and taking water and coal stops, now you can do that as well. Now, some of the other sound effects here, we're going to talk about the injectors. Now, the injector is basically how water is set into the boiler. In this particular case, we've talked about you have two types of injectors. You have a lifting or a non-lifting type injector. And what it basically does is it will take steam pressure and mix it with the water to kind of pressurize it at a higher pressure than what the boiler operates in. And then it sends it up the pipe and forces it into the boiler so that way you've got a constant water source coming. Now, with the Tsunami2, Fireman Fred does use the injector automatically, or you can turn it on automatically using function 20.
So you can kind of hear that running there in the background. And you can do this automatically, or like I said, you can let Fireman Fred do it, but you do have independent volume level on CV 147.
Now, the next up is the sander valve, and the sander valve, admittedly, it's not a very exciting sound effect, but it's there, function 21. It's just a small, slight hissing sound, and so you'll hear that.
It's very subtle. You can barely hear it on here, but you can adjust the volume level for your own take, and we'll turn them off.
And you can adjust the volume. Next up is cab chatter. Now, this is defaulted off on the steam locomotives. Fireman Fred doesn't use the cab or the radio or anything like that. But it is still defaulted on function 22. So when we type in function 22, you can start hearing some random radio conversations. And we have a handful of different sound effects built into there, different recordings that are recorded off of real radio transmissions or off of scripts. of real radio transmissions, and you can adjust that. It's there if you want to enable it for some of your more modern steam locomotives and stuff like that. And again, you can adjust the volume in CV160. Now, next up, we have our air compressor. This is the sound we've been hearing this whole time. It's selected in CV124, and we can adjust between 10 different types of air compressors, whether it's a single phase, like the one you see there down on the bottom, or a cross compound like you're seeing over on the side. Now, again, this is interactive with how you use your decoder. So as you use your brakes more frequently, you're going to hear the air compressor cycle. So just so you can hear it, we're going to go ahead and change CV124, and we're going to select a single phase compressor.
So you can hear a different air compressor there, or we can take CV124 and we're going to do a dual cross compound. So you hear those air compressors. Now, one of the ones we get asked about a lot is what's called the dual whistling for the Southern Pacific cab forwards, because we don't call it a cab forward air compressor, we call it the dual whistling cross compound. And what it is these are naturally aspirated without having to go through muffles. They're just shot right out. So we're going to go ahead and select that right now. So there's that air compressor for you guys. It's compressor number 6. So when you go through and select, you can find that on your decoder. So we're going to go back to a standard cross compound here. And then again, you have volume adjusting in CV132, so you can determine for yourself what the volume levels are.
Now, the next up is a snifter valve. The snifter is a small valve that sits on top of the chest there, and what that does is it allows steam to vent out. Where the cylinder cocks blow the water out when it's condensated, the snifter valve allows it to vent out while it's still in the steam state. And it typically sits at the top of the valve. Now, when I start to move the locomotive, you're actually going to hear a first chuff, and that first chuff is actually the snifter valve. And then when I stop, you're actually going to hear a slight pink. It's kind of like a marble dropping in a jar sound, and it's all pressurized bass. There's no manual control of this. So listen closely here.
So I'll do it again so you can hear.
So it's a very subtle sound effect, but it's there. And this, again, gives you another opportunity to more realistically control your locomotive. Now, again, volume is set in CV141, so you can adjust this for yourself. Now, the next up here is this sound you're hearing right now, and this is called the blower. The blower is a pressurized ring of steam that sits below the exhaust stack
and basically injects steam pressure up and out the stack. And what it's doing is it's creating a draft and drawing that hot air through the flues out of the firebox and up out of the stack, so that way we can keep the water going and boil the water to create the steam. And I mentioned earlier when we were selecting the exhaust chuff, there's different blower recordings and it's matched compared to the exhaust chuff. So when I change the exhaust chuff here, I'm going to select a light exhaust chuff. You're going to hear that blower change. And so you're going to hear. Now let me change it again here, and this time we're going to select a heavy or a medium exhaust chuff here.
So you can kind of hear how that's changing over the time. Now, this is one of the many sounds that are not going to disappear when you have other sounds going on because of the 16 sound channels. So again, you're going to have a more realistic experience of running the locomotive and making all the different sounds. And you can set the volume in CV134, and so you can go through and adjust that for yourself. Now, a couple of other small sounds that we've got left over is the safety valve. This is one we talked about early on. The safety valve is there to keep the boiler from getting too high a pressure and causing a boiler explosion. It's a very loud sound, and you'll hear it pop off, basically. You can adjust the probability how frequently you hear the safety valve pop off in CV208, and you can adjust the volume in 143. Now, the sound is very loud, and it's not something that you really want to have the engineers doing, because it means that they're burning up extra fuel. They're running water out the top, and so they're losing fuel, so it's not something you want to do. A little fun side story. A few years ago, we were in Orlando for the national show, and my wife and I went and visited Disney World, of course. But we did the railroad behind the scenes, and one of the things they were talking about was that they operate their boilers on their steam locomotives about 20 pounds or 10 pounds below what the safety valve set is. And the reason for that is because they're trying to create these scenes of where you're at in the park. And so that safety valve is so loud when they're running the locomotive around the park that they don't want to take a chance of ruining the experience of one area of the park, like say Frontierland or Tomorrowland or something, by a very loud steam pop-off. And so their firemen have to watch that boiler pressure very closely and make sure that they're nowhere near that safety valve, so that way they're not ruining the experience. I thought that was an interesting little side effect, but this is another one of the sound effects that we have built into the Tsunami 2. Now, some of the other sounds that you're going to hear from Fireman Fred are the wrenches. You're going to occasionally hear him turning wrenches using the grease gun. We talked about using the injector. And then one of the new ones we added that I didn't list here was the frame check. So as the engineer will walk around and you'll hear him knock on the frame testing for cracks. So these sounds will play randomly, and you can adjust the probability of each of them. Now, one of the last ones we're going to talk about here is what's called the rod clank. The rod clank is a sound that's present on every steam locomotive. If any of you guys have been watching or chasing these videos and chasing the real big boy, that thing was just freshly shopped. I mean, they just got done restoring it, and that rod clank is just about as loud as the exhaust chuff when it's running. Typically in CV 135, which is the volume, I personally set the volumes up kind of high so you can hear it. It's always present, it's always there, and it's the sound of the rod, the main rod knocking against the crank pin. So whenever we're running the locomotive, you can actually hear that rod clank.
So, like I was saying here, I'm going to get moving here so you can kind of hear. And then when I cut the throttle, there's your rod clank. So it's there all the time. Then you can adjust the volume based on the
ADE settings, but I think out of the package it's defaulted to just stay at a steady volume, so adjust that. So now that we've kind of covered a lot of all of the operation of and some of the lesser known sound effects of the Tsunami 2, let's just get into how to operate it. You know, what does all this do for me? And so with that, we'll just quickly read through these and then we'll do it. So we're going to turn on our headlight and our dynamo, so you're going to hear that spool up. We're going to blow our whistle signal, which is our F2 to blast moving forward. We're going to throw our Johnson bar, make sure we're in the forward direction. Turn on our bell, open the sander valve, open the cylinder cocks, set our throttle to speed step 1 so that we can pull the slack out of the train and allow that cylinder cock to blow out all that water before we get too pressurized. Adjust the cutoff if needed by moving our Johnson bar, and that's with our dynamic exhaust, or you can manually do it with the F5 and F6. Close the sander valve, close the cylinder cocks, and then open the throttle and get moving. So let's do a real quick reenaction real quick and just show what we were doing.
So turn on our dynamo. And we're going to blow our whistle signal. We're going to throw our Johnson bar. Turn on our bell. Crack the throttle and open the cylinder cocks. And we're going to turn on our snifter valve. I'm sorry, we're going to turn on our sander valve. Release our brakes. We can turn off our bell. Now we've been moving a little bit, so we're going to go ahead and turn off our cylinder cocks. Turn off our sander valve. And then we're going to go ahead and open the throttle up. Now, first thing we come to, of course, is the grade crossing. And we're on our way. This is just one of the ways that we can implement a lot of our sound into how you use your decoder
And how you're operating, because what this does is this involves us a lot more. It gives us a lot more fun and enjoyment, and it actually slows down our operating session quite a bit because now we're more interactive. with our sounds. So we're wanting to have the best sound systems out there. So let's show you how to use it and enjoy it more fun. So a lot of what we talked about today is showing you, a lot of the different sounds that are built into the Tsunami2, a lot of the things that you can hear. Running trains is a lot more fun and can be a lot more involved than just simply turning a throttle knob on a power pack.